So we are live. Hey everyone, this is Sibei from Dora Hacks. Thank you all for joining us today for the workshop series, episode 1 of the Dora Hacks Space Resources and Exploration Grant. Today we are very honored to invite Paulius to present a demo session representing the team Taming Particles. Taming Particles is a winning project from NASA Space Apps Challenge 2022. The team won the best use of technology by tackling the outfitting a Mars habitat, a 3D print challenge. We're very excited for his demo today. But before we kickstart the session, let me just give you a quick introduction about who we are and just a general overview of the grant's background. So for those who don't know Dora Hacks quite well enough yet, we are a global hackathon organizer and one of the world's most active developer incentive platforms. We love to support innovation in blockchain, quantum computing, space tech, and more. And we provide a wide range of toolkits to help developers around the world team up and fund their ideas and projects via hackathons, grants, bounties, etc. And this Space Resources and Exploration Grant is actually a long-term initiative by Dora Hacks to foster innovation in space tech, particularly. We've concluded the first round in June, supporting 2 amazing projects. It was a significant milestone for us, as is the very first time Dora Hacks has ventured into supporting space tech innovation. And as we are very much committed to supporting innovators in this exciting frontier, this grant program is definitely going to be one of the big focus for Dora Hacks. So right now, the second round is open for submissions until August 15th. We'd love to call all the space engineers and enthusiasts out there who are building within the industry to join us. And we can't wait to review all the submitted projects. So now let's please give a warm welcome to Paulius, who will present their winning project, Taming Particles. Just a brief summary, the team has developed a structure of interchangeable parts serving as building blocks for various systems needed on Mars after a rough landing, from waste removal to crew morale, as well as including tooling lost during landing and a rover replacement wheel as well. They demonstrated how these parts can be combined in multiple assemblies, thus saving scarce materials. Just a quick note for the audience who's with me here today. During the demo session, feel free to share any questions you may have in the YouTube or Binance Live chat room. I'll make sure to ask Paulius your questions at the end. So without further ado, I'm excited to pass the mic to Paulius. Welcome, Paulius. How about you kick it off by giving us a brief introduction about yourself and about the team, Taming Particles, before diving into the demo session. Go ahead, please.
Yes, sure. Thank you very much for having me and the team here. So first question, as is tradition, can you see the screen?
Yes, we can see it perfectly.
Nice. So so you already gave us the introduction on the team, so not gonna, on the project, so not gonna repeat it. You're gonna give a quick introduction on the team. So today I'm the only one from the team here, but we have five of us when we were participating in the challenge, and most of us work at the company Nano Avionics, which builds small satellites. And we also have another member who's not at the company yet, maybe, but is currently a student, but has lots of experience in animations and design. So feel free to reach out to any of us on LinkedIn or other platforms if you have any questions or want to talk about some research or business opportunities. So that's the team here. Now going into the challenge. So as Hibe mentioned, we were doing a NASA Space Apps 2022 challenge. So there was a list of predefined challenges, and we decided to choose the one which was the most, let's say, mechanically engineering oriented, which was called Outfitting a Mars Habitat. So it had some, let's say, boundary conditions, some hypothetical conditions, and some goals that need to be solved. So those boundary conditions were that we are supposed to imagine that we landed in Mars. Some infrastructure on it was already pre-built, such as 3D printers. So there were supposed to be three types of 3D printers: one for regolith, one for metal, and one for plastics. So using those printers, we had to basically build up the colony and all of the necessary items and things for let's see, a happy life on the red planet. Also, there was a big emphasis that during this hypothetical landing, one of the Mars rover wheels were damaged. So we were supposed to also design, let's say, a functional and sensible wheel as a replacement for that as well. So this was the challenge, and I'm going to tell you how we tried to solve it. So instead of trying to just chaotically design lots of random parts, we decided that we need some sort of structure or a catalog. So we also know that during the early, let's say, days of Mars colony, resources will be scarce. So we should do everything we can to save them. And one of the ways on how to do that is to build reusable and interchangeable items. So, for example, a handle used on a spoon it can be exactly the same as the one used on a fork. So we started thinking of this system with interchangeable parts, and basically we tried to use the system as our main selling point for this challenge. Well, instead of basically designing parts, we started designing a system which would help us to design the parts. Also, another big part of our solution, which is a bit less talked about but still very important, was topology optimization for our parts. So I will tell a bit more about this later, but basically this is an additional, let's say, selling point of our challenge, which also helps to reduce mass and reduce the materials needed for our parts. So this is the, let's say, structure I was talking about. It's very preliminary, very bare bones, but it's just to give you an idea of what we were trying to do. So we were trying to build a system where, let's say, the principal part could be made into many other parts. So like a small handle could be combined into a bigger handle. This bigger handle can be made into some other tool, and it would have, let's say, lots of different purposes. And we also looked at some available NASA resources to do this list. and we found out that there's a NASA report on deep space habitability design guidelines, and it basically describes what sort of items you would need when building a colony on a new planet. So using this list, we tried to think of what items would be most important and how we can make them modular and interconnected. So this list that we made is available in our project folder, which you can check out later if you're interested. So yeah, this is a video of what I was talking about, basically. How the parts can be interchanged. Some not ideal animations, but we were limited on time, so sorry about that. Here's a couple more pictures of parts we managed to design during the limited time we had. But most importantly, that these parts were designed with modularity in mind. So we just wanted to, instead of designing many parts, we just wanted to do a systematic approach on that. Now a little bit more about the Rover Wheel, because it was a big, let's say, part of the challenge. We gave it quite a lot of thought, and what we did was also design the wheel with the same ideas in mind, meaning modularity and lightweight. So as you can see, the wheel is made out of several different segments. So this is, first of all, to make it fit on the printer print bed, because it's not infinite. We had some boundaries for each of the printer print size bed. So we made the wheel like a pizza, and it was made out of 12, I believe, pizza slices. So this build into a rim, and then in the middle we have the hubs which hold everything together. And we even managed to run a quick SolidWorks static analysis, which showed that the wheel will survive on Mars very comfortably with I believe 3 factor of safety due to the lower gravity there. So that's it about the wheel. And now I would like to talk a bit more about the topology optimization I mentioned before. So this is like an added bonus idea on top of what was already shared. We wanted to make a system with Rhino Grasshopper, which could optimize any part you drop in it. So, for example, you have some sort of a handle, as showed in the picture on the right, but it doesn't need to be fully filled with material. For example, you only need it to carry some stuff. You only need it to be structurally stiff, let's say, in one direction by pulling up. So we made a script which would basically skeletize the part into cells, and then you can use those cells to skeletize it further into pipes. So it saves mass, but still maintains quite a lot of stiffness of the part. And you can also fine tune this script um, to adjust the let's say cell amount or pipe diameter that you want it to output. And this is actually a working script. We had it made during the hackathon, and we shared the script with NASA team. Uh, so yeah, it actually works. Of course, it's very bare bone right now, but it shows that this idea is very much possible. So yeah, this was about topology optimization. And yeah, I recently learned that um, the registration for this year's Space Apps Challenge is already open. So in case you guys are interested to tackle similar challenges and have a good time, learn new things, meet new people, be sure to register for the new event happening relatively soon. This was basically it for my presentation, and I would like to receive some questions now.
Yeah, let me see if there are any questions from the audience coming in. I'll give it a few more minutes. Meanwhile, I'll just ask some questions from myself. Thank you so much, first of all, Paulius, for the incredibly insightful demo. I really love the parts of the interchangeability of taming particles, because it is of huge importance to reduce the mass and payloads when we want to reach Mars. So I have a couple of questions for you while we have you here. The first one will be, while you guys were building the project, what were some of the main challenges you and your team encountered, and how did you manage to overcome them?
Yeah, that's a good one. So I think the main one was limited time because this was a hackathon over the weekend. So yeah, we had lots of ideas, lots of things we wanted to try and build, but in the end, there was just finite amount of time that we can work on. So this was a huge challenge because in the end we had to scrap some ideas. Some ideas were not fully realized the way we wanted. But yeah, it is. So first of all, it was time, and then another challenge is um, cooperation, I would say, because 5 team members, it's quite a lot. We have each our own ideas, so we had to find ways how to come to an agreement, let's say, on what we want to do, on what we want to show in the end. And sometimes, it's hard when you offer your idea, but the other team doesn't feel the same way about it. But you don't need to take it personally, and you need to, find the best solution for the whole team. So I guess these were the main challenges, but I think they were not, let's say, stopping us in the end.
Yeah, no, definitely you did an amazing job. So this actually brings to my second question. If you guys have more time, if you guys are given more time, or if you guys planning to further develop this project, have you thought about some like potential next steps or directions to further develop this project, maybe to bring it to next level? If so, like what specific tasks or challenges you're thinking of to work on?
Mm-hmm. Well, yeah, we didn't think that much ahead of what to do next, but some ideas that come to mind if we wanted to continue this would be the topology optimization script improvement, I think, and that would be for sure a big thing to do. And then, just trying to maybe expand a bit more on the necessary items list that are needed on Mars, and try to give a bit more thought on how more parts can be reused. Maybe invest a bit more research into how those interchangeable parts can be connected, because right now in the video, as you saw, most of the parts are connected by threads, but in some cases this may not be the ideal solution. So just there are still some open technical challenges that need to be solved. If there was, let's say, a platform, an incentive of some sorts on advancing this project, it would be quite interesting to tackle those things that I talked about.
Cool. Thanks so much for sharing more on that. Last question. I think you shared the slides of all the teammates previously. So for the audience who would like to connect with Paulius and the other teammates, feel free to reach out to them on their LinkedIn page. I think Paulius, if you can scroll back to the to your teams, the page of your teams, that would be easier for the audience to reach you if they want to have deeper conversations about the project or to discuss some potential collaborations. Meanwhile, let me check if there are any questions coming in. Anyone have any thoughts or questions? Feel free to put it in the chat room. Okay, I will just give it a few more seconds. Okay, so if there's no more questions coming from the audience, I think it's a good idea to start wrapping up today's session. So once again, Paulius, I want to say thank you for joining us today and presenting your project. It has been an incredibly insightful demo session for us. Before we wrap up, I just want to say once again, the Space Resources and Exploration Grant is a long-term initiative from DoraHacks that aims to foster space tech innovation specifically. We're very excited to have this program, and we already witnessed some great projects emerging from this program. And we encourage everyone who's building project within the space sector to join us. If you want to learn more about Space Resources and Exploration Grant or just DoraHacks in general, please don't hesitate to reach out. Visit our website at dorahacks.io. You can also follow us on Twitter at DoraHacks or connect with us on Telegram at DoraHacks Official. So with that being said, I want to say a huge thank you to Paulius one more time for taking the time to be here today. And thank you all to the audience for joining us today. And that concludes the workshop series episode 1 of the Space Resources and Exploration Grant. Thanks, everyone. We will see you soon.
Thank you.
Have a good one. Bye-bye.